Hey everybody, this is Larry. This is day 19 of the Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's poem. Um, Today I ran a easy 5-6 miles. It was pretty nice to kind of get back into running just easily. My heart rate is lower than it has been, and I've been injured for the last month or so. So yeah, it's still kind of a little bit awkward, but for jogging, it is fine. And honestly, today I've been just reading that book. I don't know if I should talk about books I read. I don't know. I read a lot, so um, yeah, I was reading that book, Careless People. The book about the what's it? Facebook's foray into uh politics, something like that. I don't know. There's a lot of stuff going on, but it's for me so far. I'm only halfway done, so because I only started yesterday or today. So it's interesting. I don't know. That's it. That's most of my day, and I bring it up because I almost forgot to do today's because I was just reading it the entire time slowly, but getting through it. So it's kind of interesting as a student of tech companies and history and stuff like that. A lot of it is I don't know. I find fairly amusing. So I don't know. But yeah. Anyway, let's take a look at today's problem. We have 3191 minimum operations to make binary arrays elements equal to 1. 1. Double ones. You give a binary array, choose any 3 consecutive elements from the array and flip all of them. Okay. Flipping an element means changing its value from 0 to 1 and 1 to 0. Okay. I think we did I think there's a tougher variation on this, but the idea is still actually is this idea I don't know the I feel like I don't know the mathematical term or foundation for this, but the way that I think about it is just that when we come to making solving these problems, I think about decisions, right? And decision, of course, is in the sense of computational decisions, right? Meaning that if you have to make a branch or something, then what happens with this branch, and that's why you have all these greedy and proofs and stuff. In this case, if you are able to look at it in a good way, or I don't know if it's a good way, but in a way, then you see that you are forced, right? In that your decision, there's no way to not do it, and it is forced. And what I mean by that, is it all ones or zeros? I actually looked at, but what I mean by that is that, for example, take a look at this, right? You look at this array, and you know that this is, and one thing is just assume a general direction. In this particular problem, I mean, there's a minimization part. Even just ignoring minimization part, you probably won't flip the same 3 elements back and forth, right? Because that's just silly. But here, looking this way, well, this is the first element is 0, right? And we want to make it a 1. Well, there's really no way, there's no choice, right? Because there's no way to go to the left. Like maybe if you had with a circular array, maybe, then you can go to the left and be like, okay, that's a choice. But here, there's actually no choice, right? If we want to make this 0 into a 1, it has to be the first element of this 3 consecutive element thing. And then what does that mean, right? That means that it's now 1 0 0 1 0 1 0 0. I mean, I know that this is probably talked about here, but I want to explain it while we do it, right? And here, okay, so then now we know that we cannot change the first digit, right? The first number, because if we change it, there's only one way to change it back, right? So you could kind of think about this as just being walled off again, because you cannot change it, because there's only one way to change it. If you change it, you have to change it back, right? So here, maybe you could even mentally just start off a new array equivalently that looks like this, right? And then now the first element is a 0. So if there's 0, then, well, again, there's no choice, right? Because there's only one thing you have to do or can do to make that a 1. There's no choice. So now you make 1, and then you do the one thing, and then there's this, right? And then of course, mentally you could chop it off again, right? And then the next thing is a 1 is fine. But in a way, there's also no choice, right? Because you're not going to change this to 0. Because if you change it to 0, then you have to change it back. So, and there's only one way to do that. So there's also no choice, right? So now you have 0, 0, 0. And then now you change it all to 1. And again, no choice, right? So what I mean by, in a way, that's what I mean by forced in problems similar to here. Because you just, every step of the way, there's no choice if you go from left to right, right? That's part of the idea for this part, and that's really it. I think it's straightforward. And of course, this one is when you can say k for some k is equal to 3 for 3 consecutive. Of course, it's an implementation problem at that point, but the idea still holds for any consecutive, right? Or at least any consecutive where it is a constant. Because there's only one choice, which is that you have to choose 3 consecutive or k consecutive or whatever. What I mean by that is if you can choose to flip 2 consecutive or 3 consecutive, then what happens? Well, now you have a lot of choices, really. At every index, you could either flip 2 or flip 3, and that, at least to me, would be a very straightforward dynamic programming problem, right? Because you have to make those 2 choices, and one way to do that is just quote unquote brute force by memorization. Anyway, we won't get into that for this problem, but these are just kind of things I wanted to bring up maybe very quickly to give you a contrast as to why or like what I mean by no choice and forced versus having a choice in these branching and forcing it, right? Okay, so now we have maybe we could I mean everything else after that is just syntax, right? So maybe something like this, where if num sub I minus 2 is equal to 0, then we have to flip, right? So I guess there's a lot of different ways you could write this. I was gonna write, I mean, I think XOR is probably like my preferred way, but I don't know, it's fine, right? So this is just to flip it from 0 to 1 or 1 to 0, right? Just to keep it a little bit consistent, right? And that's it, right? And oh yeah, and of course we have to do a count thing. And then of course there is a case where, because all the decisions are forced, there is a -1 case, right? And that is just if num sub n minus 2 is equal to 0, or num sub n minus 1 is equal to 0. Because basically here we flipped all the, because all the other ones except for the last 2 elements, we have no choice in this. We already established that we have no choice, right? So we have 2 elements left. You also have no choice. You can't flip them. So if they are ones, then you satisfy the goal. If not, then you fail. Then there's nothing else to be done. So yeah, so that's really the idea for this one. Let's see, unless I made a silly mistake, which is entirely possible. But yeah, that's it. That is all I have for this one. Yeah, let me know what you think. And yeah, stay good, stay healthy, to good mental health. I wonder if we're gonna get the part 2 version of this tomorrow. Probably, right? I think, yeah, well, we'll see. But yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.